All right, so now we're going to look at some examples covering compositions of trig functions and inverse trig functions, but using non-unit circle values. So last class, we looked at compositions where we had unit circle values. So like cosine of 5 pi over 6, or we had arc cosine of 0, right? Where those are things we can use the unit circle to figure out. But if I have like cosine inverse of 8 over 17, I know that 8 over 17 is not a unit circle value, so I'm gonna have to take a different approach. So let's look at number 25. So we want to figure out the tangent of the cosine inverse of 8 over 17. So we have some steps here that we're going to look at. So the first thing we're going to think about is letting the inside equal theta. All right. So since we know we have a cosine inverse trig functions, their outputs give angles. So I'm going to call the inverse trig here in the middle, or in the inside, theta. So what this tells me is that the cosine of theta of some angle equals 8 over 17. So in this case, instead of using the unit circle, we're going to be using all right, so now we need to figure out what quadrant does this mystery angle have to be in. So there's two things we have to consider. We know that cosine here is 8 over 17. That's a positive number. So cosine of theta is positive. And so we know from our knowledge of trig, all students calculus, that cosine is going to be positive in quadrants 1 and quadrants 4. But there's also another condition here. We have the cosine inverse, and we know that cosine inverse exists only in quadrants 1 and 2. So we need to figure out where they overlap. Well, they overlap in quadrant 1. So that's where our angle is going to be. So this tells us that theta is in Q1. So I'm going to go ahead and draw my angle, or my triangle here. So we start from the origin, then drop down to the x-axis and put theta in the corner. And since we know that cosine is 8 over 17, cosine is adjacent over hypotenuse. So the adjacent side is 8, hypotenuse is 17. So we need to figure out what this side here we'll call B is, and we can just use the Pythagorean theorem. So we know that 8 squared plus B squared is going to be 17 squared. So we have 64 plus B squared equals 289. So subtracting 64 from both sides gives B squared equals 225. Square root both sides. B is going to be plus or minus 15. But since B is this vertical distance here, B is just going to be positive 15. All right, so now we have all our sides. So now let's answer the question. So our original question was to figure out the tangent of this angle here. So we have theta in the corner, and we want to figure out what's the tangent of this angle theta. So the tangent is going to be opposite over adjacent. So to finish this off, we're going to say that the tangent of theta equals 15 over 8. So that would be the value of this composition. All right, 26, we have sine of the arc tangent of negative 12 over 5. Notice that negative 12 over 5 is not a unit circle value that we know, so we're going to need to use these the triangles to help us out. So the first thing we're going to do is start by setting the inside of this composition equal to theta, because I know inverse trig values give outputs. So this tells me that tangent of theta equals negative 12 over 5. So now I have to think about what quadrant theta is going to be in. So I have two things to consider. We know that tangent is negative. So where is tangent negative? Well, I know tangent is positive in quadrants 1 and 3. So it has to be negative in quadrants 2 and 4. But then we also know that we have to consider the restrictions for arctangent, right? And so we know that arctangent exists in quadrants 1 and 4. So where's the overlap? The overlap is going to be in quadrant 4. So this tells us that theta is in Q4. So I'm going to draw a quadrant 4 triangle. And theta is in the corner. So when I label my sides, we know that tangent is opposite over adjacent. So the opposite side is going to be length -12. And the adjacent side is going to be length 5. So now I need to figure out what is the length of the hypotenuse here. So we're going to use Pythagorean theorem. Our hypotenuse is always C. So we're going to have 5 squared plus -12 squared equals C squared. So 25 plus 144 equals C squared. 169 equals C squared. Square root both sides. C is plus or minus 13. But since the distance from the origin is always going to be positive, we can then conclude that C equals 13. Okay, so that's my C value. So now we can go ahead and solve our, answer our question. We want to figure out the sine of this angle theta, right? So I have theta here, and to get sine, I do opposite over hypotenuse. So we're going to have -12 over 13. So my sine of theta equals -12 over 13. So that would be the value of this composition. All right, the last thing we're going to talk about is how to write trig functions as algebraic expressions. So same thing, we have a composition, but now we have a variable on the inside. But it doesn't really change how we approach it. We're still going to do the same thing. We're going to first start by writing our inside, our inverse trig, as theta. Okay, so we have the sine of arc cosine of 3x. And so I'm going to think about the inside here, the arc cosine piece, as just theta. So what this tells me is that the cosine of theta equals 3x. All right. Now, since x is between 0 and 1/3, that means that we're going to stay in Q1. So for these, just for simplicity, we're going to be in quadrant 1. All right. So I'm going to draw an angle, or a triangle rather. Theta is in the corner. And we know that cosine of theta is 3x. So cosine, and as a ratio, we need, cosine to be a ratio. So 3x is the same thing as 3x over 1. So I can think about my 3x as my adjacent and 1 as my hypotenuse. So I'm going to go ahead and do that. 1 is my hypotenuse, adjacent. So we need to figure out what is this opposite side here. So I'm going to label that as B. And we're going to figure out what B is using Pythagorean theorem. So we have 3x quantity squared, a squared plus b squared equals 1 squared. So squaring 3x gives me 9x squared plus b squared equals 1. So to solve for b, subtract 9x squared from both sides. B squared equals 1 minus 9x squared. Square root both sides. B equals the square root of 1 minus 9x squared. And we're assuming the positive value since we're in quadrant 1. So that's my B. Now let's answer the question. I want the sine of arc cosine of 3x. So I need the sine of theta. So to do sine, I do opposite over hypotenuse. So to finish this off, we have that sine of theta equals the square root of 1 minus 9x squared divided by 1, which is the square root of 1 minus 9x squared. All right. So I've taken this expression with trig and inverse trig and converted it to just an algebraic expression in terms of x. All right, last one, we have cotangent of arc cosine of 3x. So same triangle really as before, right? Because we have the arc cosine of 3x and arc cosine of 3x. So I'm just going to go ahead and do the same sketch here to just save myself some time. We already know we're going to have the triangle that has the same sides, 3x square root of 1 minus 9x squared and 1. If it was a different inverse trig, I'd do the calculations and figure out the triangle, but I'm not going to here since it's the same thing. So now I want cotangent, though. I want cotangent of this angle theta. So since theta is in the corner, the cotangent is going to be, well, tangent is opposite over adjacent. Cotangent is the reciprocal, so cotangent is going to be adjacent over opposite. So it's going to be adjacent over the opposite. So cotangent of theta is going to be adjacent over opposite. All right, now you could stop there. Now I know we talked about how you can't really have a square root in the denominator, so we're going to just go ahead and rationalize this by multiplying numerator and denominator by that radical. So this is going to give us 3x times the square root of 1 minus 9x squared. And then when I multiply square roots, they undo each other. So I'm just going to get 1 minus 9x squared. So this would be my algebraic expression.